If you're listening to this, I'm guessing that you probably have a ruler. And this ruler has little divisions in them that say millimeter and centimeter and meters. And I'm guessing that you've used these all your life, but you have absolutely no idea why we use those divisions and not others, and where all these things of meters, centimeters, and things like that come from. Now, of course, you know that meters measure length, because everybody knows that. But why do we use meters to measure length? And let me show you what I mean. So, for example, imagine that I have a table. This is my table. It's a pretty crappy table. Okay, now the legs are a little bigger. So anyway, I have this weird tilted table, and I would like to know its length. But imagine that you were born, I don't know, 20,000 years ago, when there were no meters. But you had to tell somebody else how long your table was because, for example, you wanted them to make another table just like it. Well, how could you do it? You don't have a meter. You can't tell them, well, the table is 3 meters long. So what do? Now, one option is to use your hand, right? So you just put your hand in here, and you're like, okay, this is my hand, and I can put it 1, 2, 3, 4, 5 times here. So my table is 5 hands long. Well, that's great, but of course, your hand and the other person's hand might not be exactly the same. So you're going to get a table that's roughly the same size as yours, but not exactly. Other people, for example, used an arm's length. I don't know if you've ever heard of the cubit, but the cubit was the length from the elbow until the hand, this length here. And this is what the Egyptians used to measure their length. Of course, you soon realize that these things are not very practical. When you want something to be exact, and for example, if you're making a building, it's a good idea for things to be exact, because otherwise, buildings fall. So if you want this to be exact, you can't just give measurements in, cubits or hands or whatever. You need to have some sort of standard so that everybody can understand. The SI unit is exactly that. It's an attempt, in this case by the French, of finding a system of units that everybody can agree on so that we can all understand each other when we make measurements. And this is no laughing matter. For example, the Americans refused to use the SI units, and there have been problems because Europeans would measure things in meters, they wouldn't measure things in inches, and then, this caused things like rockets to malfunction because the scientists, for example, forgot to do the conversion from one unit to the other. Now, there are 3 fundamental SI units, and what I mean by fundamental will be clear relatively soon. So there's 3 units that we use to measure everything, and those are the meter, the second, and weirdly enough, the kilogram. Now, we don't use the gram because it's too small, so it's not very practical, so we just use the kilogram, which is a little bigger. So the idea is that with these 3 units, I can make most of the other units we use in our daily life. So for example, this is a unit of length, but if I want to measure area, I just need this squared. If I want to measure volume, then I just need this cubed. If I want to measure speed, I need meters and seconds, so I just need these 2. So basically, I can combine these 3 units in different ways to make up the rest of the units. That's why we normally call them the 3 fundamental SI units. There's other SI units, but they're all derived from these ones. They're combinations of these 3. So the basic idea here is we have 3 units that we use so that it's easy to communicate with other scientists or just other regular people, so that we can all agree on how much something measures without having to resort to, it's 5 of my hands and a half, which would be very inconvenient. Now, what happens is that those 3 units sometimes are very convenient, but sometimes they're not so convenient. So, for example, if I want to tell you how far Augsburg is from here, I have to say something like, it's 70,000 meters away. That's not great. If I have to tell you how far the sun is from here, I'm going to give you a very, very big number in meters. And most of the time, it's really hard to mentally deal with something like 20 and then like a bunch of zeros meters. So what we do is we use different units. These are units that are not SI units, but that they're derived from those units simply by adding something called a multiplier. And I'm sure that you guys are familiar with this, but the idea is that this is systematic. So for example, instead of talking about meters, when we talk about distances to cities, right, we talk about kilometers. And 1 kilometer is just 1,000 meters. Or instead of talking about seconds, when we talk about the movement of a molecule, so we use milliseconds. And 1 millisecond equals 1,000th of a meter. And the idea is that these things here, they're called the multipliers, and they modify the unit that goes afterwards. So if I put a K before an M, this really means that it's 1,000 meters. Or if I put a little m before an s, this means 1 millisecond or 1,000th of a second, and so on. But this will also work if instead of having a second here, I had a meter here. So for example, 1 millimeter is 1,000th of a meter. 1 milligram is 1,000th of a gram, and so on. Now, I am not going to go through all the list of multipliers because I would go insane, you would go insane, everybody would go insane. Instead, I'm putting it right next to this video in the Google form that you're using. And what I want you to do is to go through all the multipliers. The highest one that you need to know is giga, so which is approximately 1 billion of whatever comes after, and the smaller one that you need to know is nano, and you can just ignore the other ones. So anything in between is something that you need to know. So what I would like you to do is to just go over those, revise them, then after you're done with this, it will send you back to the questions at the beginning, and you can try again. If you get one wrong, you will be sent back to the video and to the list of multipliers, and we will keep doing this over and over and over until you finally get them all right, and then you'll be able to move on. So, good luck.